we'll do some addition of two numbers. Okay, or concatenation of first name and last name. Console.write line, enter your first name. So we'll ask user to enter his first name, string f name equals console dot read line. Why? Because we have to read the entire line, right? Line of characters. So next, similarly, we will take last name. So here, L name. Okay. So next, what is full name? How to concatenate string full name equals to first name plus first name plus last name. Next, we'll give console.write full name. We'll just display the full name. That is one way. Or if you want to display like this, like this also we can display. So now, for example, here instead of name, I want to take number. First number, second. So here to take the number I need int. So once it is int, here we are getting error because console.read line will give you in the form of string, but here we want output in the form of integer. So what we have to do? We have to convert dot to int 32. What is 32? By default, int size will be 32 bits. So here you use int dot first number 10, second number 20. We'll get the output is 30 like this. So what are the different types of data types available in okay, so now I'll take a new file. So here we will see what are the different types of data types in C#. Data types in C#. What are the different data types? We have int to store the numbers. Okay. Numeric values. There are three types of integers will be there. Int 16, which is 2 bytes. We will also call it as short. Int 32. By default, int size will be 32 bits. 2 bytes. Int. This is your normal int. Next, int 64. This is your 4 bytes. This is your long. Okay. Now, this is our integer. Again, there are two types of integers: short, U short. U stands for unary, means which will take only positive numbers. Similarly, integer also there are two types: int or uint, long or ulong. Okay. So this is for int. Second, we have float to store floating point numbers. So which will take 4 bytes. So if you want more than that, we'll go for double. This is also floating point number, but it is 8 bytes. So next we have decimal numbers with digits. For example, if you want to store any currency, money, such type of things, we'll go for this. Okay. Next, we have Boolean to store Boolean value, either true or false. So what is true indicates? True indicates 1, and false it will indicate with 0. We have char to store the characters like this, and we have string. We want to store the names like this. We have data to store. Finally, we have an object to store anything. Inside the object, you can store any value. It can allow anything. So above all are a particular type only, but this can accept any type. It can accept anything to store any value, any type of value. There is no restriction. So you can store integer, float, double, decimal, boolean, character, collection of integers, number of integers, like that. You can store inside the object. Float and double both will store the floating point values only, but only the difference is size. Float can allow 4 bytes of memory. Okay, up to 4 bytes. So if you want more than that, then you go for double. Okay, this is to store the floating point numbers, which is like fractional values. Okay, how the float looks like this. So like this. 3 point. So there will be a lot of so usually in research centers and all. So these are the machine generated values. Okay. So there are two things we have. So one is value types and reference types. Value types which holds the value directly. For example, integer x equals to 10 means it will hold the value 10 directly. This is value type, and this will use stack memory. So value type means which holds the value directly. For example, integer x equals to 10 means it will hold the value x directly having the value. So for this to store the value types, it uses stack memory to store. So where value types will store? It will store in stack memory. So what are the examples for value types? We have examples like primitive types like int, float, double, decimal, char, bool. All these things we have discussed just now. So all these are apart from string. String will come in reference type. Okay, all these types will come as the value type. Along with that, there are two more called struct, structure, and enumeration. This we'll see later how this will work. Okay. And inside this reference type, okay. So next, in reference type, which will store the address. It directly won't store the value, it will store the address. For example, if you see here, heap memory. Since it is a reference type, it will use heap memory to store. So this, instead of directly storing the value, it will store the address. For example, int x equals to 10, int star y. Y is storing the address of x. X storing the value of 10, like this. So this is a reference type. Okay. So this will store the address instead of value directly, and it uses heap memory. And what are the examples for reference type? We have string, object, interface, event, delegate, class, array. These are all the examples for the reference type. Apart from string, these are all new things. We'll see it later. This is stack memory. This is heap memory. Let's search. Okay. So stack memory means, for example, int x equals to 10. Means x having value of 10. There is a fixed size, fixed place, same reference. Here, int x equals to, or star a equals to b. Equals to 20. Let's assume we have values like this. Int b equals to 20, int a equals to star b. Means we have a here. In a, what you are storing? You are storing the address of b variable. So what is b variable? This is b variable. B variable will have some value called 20, and this is, there is address 037xy27. This is my address, memory address. Here in A, we are storing the just address of the B value, so that what will happen? A is calling B address, B is pointing to this address. This address will have the actual value of 20. Understood? Yeah. This is how. This is called heap memory, reference type. There won't be any particular place to store. Wherever memory gap is there, it will go and occupy there. So here it is a fixed size. Integer means this much of size will be occupied, 2 bytes, 3 bytes. Only that memory it will store. And heap, it's not like that. Dynamically it will get increased. Okay, there won't be any fixed place of memory. So wherever free space is there, it will go and occupy there. Okay. Yeah. So and stack, if you create stack manually, you have to do the cleanup. So heap automatically cleaned by garbage collector. There is a feature called garbage collector. We'll see now.
That's the generation 0.
Yes. So there are 3 different types of variables. constant, static, read only. So what is this three? Okay. So for example, if you give constant at the time of declaration,
So these are types of what?
variables at the time of declaration, not mandatory to assign the value. To assign the value. So in constructor, we can assign the value, but during the runtime, it acts like a string.
So it's constructor.
Constructor will discuss. Constructor is a special member of the class to initialize the class members. Okay. And static, no need of object creation. We can access with class reference. So how to create object, what is class, we can see later. Okay. Thank you for watching.